Good day, Bayaos. For today's video, we will solve the sample number 2 in chapter 1, properties of the fluid. So our problem is, a rigid steel container is partially filled with a liquid at 15 atmosphere. The volume of the liquid is 1.23,200 liter. At a pressure of 30 atmosphere, the volume of the fluid is 1.23,100 liter. Find the average bulk modulus of elasticity of the liquid over the given range of pressure if the temperature after compression is allowed to return to its initial value. What is the coefficient of compressibility? The first thing we do in solving a problem is to determine the given value. As you can see, we have our pressure and the volume. So our pressure 1 is 15 atmosphere and the pressure 2 is 30 atmosphere. In other hand, we have volume 1 which is 1.23,200 liter and our volume 2 is 1.23,100 liter. In this problem, we are asked to find its average bulk modulus of elasticity of the liquid over the given range of the pressure if the temperature after compression is allowed to return to its initial value. And the second one, what is the coefficient of compressibility? Since we are asked to solve the bulk modulus of elasticity, of course we will use the formula of the bulk modulus of elasticity. Given the formula of the bulk modulus of elasticity, change in pressure or the P2 minus P1 over the negative change of volume, which is V2 minus V1 over the initial volume. So to simplify it, we have the formula of negative V1 times P2 minus pressure 1 over volume 2 minus V1. So this is our formula to use in our solution. We simplified it so that it is easy for us to substitute the given formula in our formula. So the given value in our formula. So our solution is, but before that, if you are wondering why I didn't put the formula for compressibility, it is because the formula of it is the reciprocal of the bulk modulus of elasticity. You can see it in our solution. And bulk modulus of elasticity is a measure of the ability of a substance to withstand changes in volume when under compression on all sides. It is equal to the quotient of the applied pressure divided by the relative deformation or the volumetric strain. To get the average bulk modulus of elasticity using the given formula, which is this, so we have negative our volume 1, which is 1.23,200 liters times P2 minus P1. So our P2 is 30 atmosphere minus P1, which is 15 atmosphere. We will convert the atmosphere into kPa. So in 1 atmosphere, there is 101.325 kilopascal over our V2, which is our volume 2, 1.23,100 liter minus V1, which is 1.23,200 liters. So if we will put this in our scientific calculator, if we will put this equation to our scientific calculator, we can have the answer of 1,872,486 kilopascal. So if you want to have a decimal point or a decimal value, we will convert the kilopascal to gigapascal. So from 1,872,486 kilopascal times in 1 gigapascal, there is 1 million kilopascal. So we will put this equation to our scientific calculator. We have the answer of 1.872 gigapascal. So this is the answer of the average bulk modulus of elasticity of the liquid over the given range of the pressure if the temperature after compression is allowed to return to its initial value. So the coefficient of compressibility is a reciprocal of bulk modulus of elasticity. So just like what I've said a while ago, this is to in getting the compressibility is by reciprocating the value of bulk modulus of elasticity. So 1 over our bulk modulus of elasticity, which is 1.872 gigapascal. So if we will put this equation into our scientific calculator, we have the answer of 0.534 gigapascal raised to the power of -1. So we will raise it to -1 since it is reciprocal. So this 0.534 gigapascal raised to the power of -1 is the answer of coefficient of compressibility. So I hope you learned from my video tutorial by Yav. So thank you and God bless everyone.